In this video, we are going to discuss about the inverse matrix using the graphing calculator, either TI-83 or 84. If a matrix is given as A, the inverse of a matrix is denoted by the symbol A inverse. Now let us try to learn how to get the inverse of a given matrix. Let's take these given examples. Three matrices are given. A is a matrix of 2 by 2, that is, it has 2 rows and 2 columns. And B is a square matrix of order 3. C is a square matrix of order 4. Usually, the inverse matrix, when you are trying to find, we have to check whether it is a square matrix or not, because the inverse of a square matrix only will exist. Using our graphing calculator, we can find that the A inverse is also a 2 by 2 matrix, which is -3, -4, 1, 1. B inverse and C inverse as given in the slide. So let us see how to get these values, the A inverse, B inverse, C inverse for the given matrices using our graphing calculator. So in order to find the inverse matrix using our graphing calculator, let us enter the matrix in our graphing calculator. Let us assume that we are trying to find the inverse of the first matrix A. First, we have to enter the matrix A in our calculator by pressing second matrix. The matrix is just above the symbol and the key X minus. So second matrix, under that edit, the first matrix is a 2 by 2 matrix. Enter the rows and columns of the matrix A. Then, in order to find the inverse of this matrix, let us take that matrix A and use that key X inverse to get the inverse of a matrix. With the X inverse is just below math. So using that key, we can find the inverse of the matrix, which is -3, -4, 1, 1. We can also check whether the matrix what we got is a correct answer or not by multiplying A and A inverse. When we multiply those two, it must give an unit matrix, a 2 by 2 unit matrix 1, 0, 0, 1. Yes, it gives the unit matrix. So the matrix -3, -4, 1, 4 is the inverse of the given matrix A, which is 1, 4, -1, -3. The same way, in order to find the inverses of B and C, we can enter those values B and C and then multiply B inverse, C inverse to check whether the product is a unit matrix or not. So we get the product to be a unit matrix in all the cases, so we can easily get the inverses of these matrices. If A is a given matrix, then the inverse of that matrix is denoted by A inverse. And if A inverse is an inverse matrix, then the product A inverse or A inverse A must be the identity matrix I. The identity matrix is always a matrix which is given with the leading diagonal to be 1. The remaining terms are all 0, that is our unit matrix. It is always a square matrix. So if it is of 3 by 3, we usually call that as I3. So in our case, since we took a 2 by 2, 3 by 3 and 4 by 4 matrices, we got the identity matrices I2, I3 and I4 as in the verification. And also, the inverse matrix will exist only if the given matrix is a square matrix and also if the matrix is non-singular. A matrix is said to be non-singular if the determinant of that is not 0. It is a separate concept. Maybe in our next chapter we will try to learn how to find the determinant of a matrix. So this is another way of checking whether the inverse exists or not. We have to see whether the given matrix is a square matrix, and if the determinant is not 0, then definitely the inverse of the matrix will exist. So in this video, we talked about the inverse matrix using TI 83 and 84. We used three examples, one a 2 by 2 matrix, the other one a 3 by 3 matrix, and the third one was a 4 by 4 matrix. This is applicable for any order, even if it is of order 6 or 7, we can still use the same method to find the inverse of the matrix. Getting the inverse matrix using TI 83 or 84 is quite easy. Hope this video was helpful. Thank you for listening and thank you for watching this video. Thank you.